Okay, till that going on, we can start. Everyone have, I assume, that the Google account has been logged in the Google Earth Engine. So anybody in here know why we use Google Earth Engine? I mean, traditional basic way, I think Dr. Emanuel has already talked with you guys. Like, you need to download the data from the USGS website or any other the data providing Earth data or some other satellite image providing website. Normally, like one of the, like if you for a research purpose, I mean, not like one image we are not downloading, because if you are doing for like climate studies, at least you need to go more than 15 years, like 20 years close to, because most of the research that the people in the meteorology field that we also doing, we are like try to combine it to the climate, not only like daily like meteorology, just not one image. So for example, my experience, if it's like for me, one set of data for 15 years, if it's like daily data, it goes for like 2 TB close to. But that kind of like maximum amount of like those, even though you downloaded like Landsat images for like 15 years consecutively, you may find some dates that there are clouds. So if it's clouds, then the cloud cover will block our image. For example, if we, that's the truth. For example, the satellites in here, and any satellite, let's say like you are using like in the satellites, I think in here most of the people knows that satellites not only take like this visual radiation, visual range of images, but also we have IR and different kind of like sensors that we are using. So let's say like visual images, for example, for land surface monitoring, visual images are we are using mostly. But if it goes for like X-ray images, the cloud doesn't matter. So even though we like cloud is over there, but cloud can be penetrated by the X-ray images. But for the visual, the range of the images that we are using will be blocked by the cloud. If there's a cloud in the image of the land surface, then we have a percentage of cloud has been blocked. So in the USGS satellite, we have an option to filter the data that if you have a cloud cover of this, but even though there are some of the images that can become, the algorithm of the USGS satellite might not work. So you may have less of images. So in the Google Earth Engine, we don't have to download this much of big amount of data. We can easily use the Google servers, and the data is stored on over their servers. So we don't have to download. First thing, you don't need like a higher end computer. Like you don't need like a good GPU or something that can be process image. You don't need like big RAM. You can use for base model of a computer is enough for the Google Earth Engine. Because in the Google Earth Engine, we are using basically the processing power of the Google clouds. So that is why that you have to like accept the Google Cloud Services agreements and things like that. And this Google service, Google Earth Engine as well, have limitation for the free version. Because for the students, they only give like a limited time of a limited area of computation power. Because for example, 2 TB data, like a lot of people using the Google service might be down within 1 day if they give unlimited. But if you are like corporate version, if you need unlimited access power, Google Earth Engine also have paid version that also you can use, but it's expensive. Like for a small amount, maybe $500 US. So it's expensive when it comes to using their own servers for non-commercial usage. So in here, how many people are using Landsat satellite? Or some of the people who are using Landsat, you're using Landsat satellite. Anyone in here? Try to communicate with me, because I don't like to teach like on the presentation. I'm not a person who's like writing everything on the presentation, so I just communicate with the people. You also using the Landsat satellite. So how about like MODI series that we do have? MODIs, Sampler, Sentinel as Sentinel also you are using. So we have different like capabilities of this. For example, modis, it takes a lot of images, but the problem of modis is it's give less resolution, but the time of the taking the images is so much good. Yes, if you go for the world scale, so that's why, like, I think in the first semester we had one of the lecture from the doctor who's the previous Kiatang Oo. He did something about the data, how to choose the data and things like that. So when you're doing a research or idea, first you need to read the papers and identify what kind of satellite data we do need. Because for Landsat, it's useless for something like you go for large area, because Landsat images are resolution is good, but it don't give like too much satellite images. For example, we had like recent unfortunate incident earthquake on the Myanmar previously, but I was trying to do this research based on the Myanmar, so we can like calculate end of the session how much devastation that can be happen from the algorithm that I'm teaching to you guys. But the problem is the satellite not yet has go over there. We have much data of the satellite. It's a good quality image, but we need an image on April. Maybe like after you learning, you may like in middle of the session, we can try to like, you know, focus onto the Myanmar and finish some assignment or something like that. So we can calculate how much, you know, problem happened in the area of Yangon, how much the percentage of building has been collapsed, things like that. We can calculate based on the knowledge that we know. So remote sensing is basically not 100% accurate unless you have valid ground station data. So for example, when it comes to my field, the aerosol, we using the ground station, the aeronet or something is freely available. Aeronet for aerosol, the people who are doing for aerosol. But for the people, let's say like, let's say something like, no, when me and Dinesh worked back in Sri Lanka, we took the images and we run these things for deforestation. Back when I was working, we did one research on deforestation. So we calculate how much deforestation that happened within the country and area. But again, the data has to be when it is published according to our, because we are a government body at the time. So our data, whatever the published or research, the report that we are giving to the government has to be accurate. It's not for like, you know, elsewhere or something. So we need to like check. So we went to the ground station and the exact locations, and we calculated how much percentage of damage that happened, and we validate some of the points that has been spotted and the areas that has been spotted on the deforestation area, and we validate them with the research, the remote sensing data that we got. So if you are like, you know, it's best again for the elsewhere or something, then for a normal publication research wise, you can go ahead with the remote sensing. But for example, like when you are going for like environmental impact report or something that is being used for a project or something that the government is using, you can, you know, you have resources. Deforestation, you can calculate. And the same time, the exact location of the earthquake, the damages, also you can go and check, but if you are in Myanmar, not from outside. So those things like you can check, you have to validate, for example, as I said. And let's go and check on what we will go. Okay, I have talked about the advantages of the Google Earth Engine. So the advantages of the Google Earth Engine, can anybody tell me? I have already talked. Anyone? You don't need to download. Yes, you don't need to download. Yes, we can directly work. So anything else? Time spin. Yes, those are the main things that the Google Earth Engine is helping for. So whatever the things that you can do on the, you have learned a lot in ArcGIS, I'm assumed, because I know that the previous doctor has been talked a lot on this one, because he was back in his country as a trainer on specifically in the university or he's working. So you can use the Google Earth Engine for the downloading the data only as well. No need to like go for the process. Anybody here have like experience in programming? Anybody have experience in programming? Any kind of JavaScripting, HTML? Not you. He's raising the hand. He's a senior software back in the country. So anybody in here have any experience? No experience? But the thing in the China is like Chinese bachelors, because I did my bachelor's in China with Dinesh in 2017. In China, whatever the major you learn, even that art subject as well, you learn programming. So that's kind of like thing that help, because for us, like we don't need to like code. For us, it's like, you know, you see the code, you understand the code. That's the meaning important thing. You just read the code, because codes are over there, people who have already created. Now we have ChatGPT. Why we have to use? We are not using ChatGPT. In our university, it's not a ban to use ChatGPT, but you cannot use the entire thing on ChatGPT. Like, you know, your entire research on ChatGPT. Like, you know, here are some conclusions that I can give. I am not an AI in middle of the research that you cannot find this one. So you can use the ChatGPT. There's no problem. ChatGPT is there. You can use the ChatGPT for here as well, for Google Earth Engine as well. There's no problem, because AI is over there. So whatever that you are doing, you need to learn how to read the code, how to, like, you know, what this exact code has been told. I think most of you here have already done, like, you know, hello world, Python hello world or something, you know, just in Java as well, print, you know, hello world, just take the print out at the hello world. So those are also like basic. Just reading about what are the things we can go. You don't need to think about like the architecture of the code. Just read the code. And whatever the thing in the coding is, like, basically, just for me, my experience, Dinesh have more experience on coding than me. I'm asking most of things from him as well. So from my perspective, what I'm doing is, like, whenever that you open, like, you know, small things, like, you know, you open a, like, you know, calling from downstairs to the up. So upstairs, whatever the string that you have open, you have to go and mention in the same name or things like that. So because in the ChatGPT also, you like different process, you may call different time you search, but this code has to be combined. So those combined, like, string names has to be same. Only those things has to be, like, you know, keep in mind, because other things exactly coming from ChatGPT, whatever the AI software use, DeepSeek also good. So let's go for the Earth Engine. Let's directly go into the Earth Engine. We have talked about the background and everything about the Earth Engine, and I will turn on. You can also turn on your Google Chrome. I think it comes from here. Oh, you don't need to like download, go for this exact URL. You can just search on the Google. Google Earth Engine. Just go to the Google and search Google Earth Engine. And you can go inside. So everybody who searched and the Google Earth Engine in the Google and go into here, first you need to turn on the VPN, obviously, because you're in China. And you have to go for the code editor. You can just go for here. In here, the platforms, you have the code editor, where that we have been using for code, editing the code. But first, before going for the code editor, this is the code editor, okay? This is the code editor. I will go for the code editor. Before that, what are the data sets that is available on Google Earth Engine? You can search. Okay. So we can search all the data sets that they have. So you all are in here, in this workplace. Huh? So in the data, you have different type of data. You have data products, and I mean the raw data as well. If somebody wants the raw data, you can download the raw data. But the process of using the raw data is little bit high. But sometimes you can use like product of data. For aerosols, like if I say on the aerosol side, anybody in here working on aerosols? Atmospheric aerosols? No one? No one. Oh, over there. Okay, previous my major was applied meteorology. At the time, I used to do land surface remote sensing. That's my research background. I will tell first. My research background is first I was did the during my bachelor's and master's applied meteorology for my master's and the bachelor's as well. So my research focus is on the urban heat islands and the land surface changes. So LULC, land use, land classification, and land surface temperature. So things like that. And after that, when it comes to PhD, now I'm working on aerosol. But in the aerosol as well, I'm combining these changes, like the land surface changes and how it has been interact over the climates with the aerosol and with the aerosol impact onto the climate, because aerosol can be impact on different methods. So that's how I changed my research field in the PhD, because rather than going for same like applied meteorology, I went to atmospheric physics and on atmospheric remote sensing. So in here, you have different products. For example, these are like the DEM, digital elevation model, from different areas. So for example, if you want anything, let's say like you can search in here, Landsat. Okay, my network is little bit slow. It's not searching. So in here, when you search, you will get the land surface, Landsat. So you can see like the image has not downloaded in here. The USGS Landsat, these are products. This is a rosin, and let me first check my internet first. Like, give me 1 second. You're also not working? Let me check my VPN. Gini Swami, bikin kan? Hotspot ini. Mungkin මෙතනින් ගත්තා නම් okay. If it's not working, you can just go from here, from the categories. Okay, now it's loaded. So Landsat, we have let's say Landsat satellite series. Landsat is good for land surface, any research that is based on the land surface, because it has different. You can go like different satellite have different sensors. So this one, like for example, if this Landsat 9, I don't think like good for like for a research, but it has a good enhanced capability of imaging. But the problem is like when it comes to like long term, because for my area, for example, it needed a like long time of data. So this one is only give like 2021 onwards only, and Landsat 8 gives 2013 onwards. Landsat 7 gives from 1999 to 2021. So the Landsat 8 is still working. So if I example, so these are the sensors they do have. For example, I will go inside of the Landsat 8, and once you go inside, the images and the products they have, all the information of the Landsat will be given in here. So if you read this one, it has the tier 1 and tier 2 data, but tier 1 already be retired, most of the data products. So go for the try to go for tier 2. So this one is a surface reflectance data. This is top of atmospheric data. This is the raw images. So surface reflectance, if you go for like for research, something like calculating urban heat islands, like not only urban heat islands, like surface urban heat, surface heat, you can go for the surface reflectance. It's a passive remote sensing, not active remote sensing. So let's go for the tier 2 of the data set. So inside it gives like what are the data it has available. This has data since 2013, the date 18 to up to now, the present. So the latest image they have got is 2025, the 330, March 30th. Okay. So that is the main problem that happens. I think this Myanmar, the problem happened on 29, no 30th, 28th. So the image is not over there yet. The satellite has been not went. So let's go for the bands that this is providing. So these are the bands. Bands means like in the image, what are the bands that you can use? Like I think you have used the RGB on when you have you downloaded the data when with the Dr. Emanuel, and you have already opened it on the ArcGIS. So you have selected the bands, the blue, red, and things like that. So yeah, so these things also see in here you can see the blue, the green, red, the data, what we call the sensor is been mentioned when you are selecting the image. Whatever the product that you want to use, the band has been mentioned. So you can easily. So this is the data description. Everything about the satellite, the image that you are downloading is coming to here. So you just need to call when it comes to like in the ArcGIS when you are coding, you can call SRB2. So you can familiarize with all the things. And in here, if you go into the down of all the data categories, the Google Earth Engine itself has been provided its own code. So you don't need to, again, that's why I told you, These codes are available. You don't need to like think like, you know, something like Albert Einstein or something that you are like, you know, code, not Albert Einstein is for mathematics, no, something like code genius, like a software engineer who's like a pro software code, you know, like a hacker or something. You don't need to think something like that. Just the codes are available over there. You just need like, you know, search in the GitHub or somewhere that the code that you need to be fine. Then after that, the knowledge that you have needed is just how to read the code. In here, for example, the this code, this is a variable in the JavaScript. This is in JavaScript. See, the code is in JavaScript. This one can do like Python and JavaScript both. But for Python, you cannot code in here. You have to go for its own terminal. JavaScript, you can code in the code editor. My thing is like we learned this one on in my bachelor's is Java, the programming of Java. So I know the JavaScripting is much better than for me Python. So I'm using JavaScript, and it's easy to use in the code editor. So in here, the variable, the data set, so it has been open a variable in here. Small things. It open a variable. The variable name is dataset. This name you can change, like you can put your name in here, but it's best like you put something like, you know, common, because if someone is reading, they can understand easily. The variable dataset, this is EE image collection, this Landsat. This is the data range. So how he get this one? This EE image, if you go in the data in the top, see, Earth engine snip. So you just need to use this one. Whenever that you call a variable, like variable, let's say IMSA, variable IMSA, and you put EE collection Landsat, this thing, then we are calling the data set into the JavaScript. So let's run this one and check. You just go into the down and put the open in the code editor. If you have already give the permissions, then it will be open like that. And run. It will be open, and it needed to be used like this. So this is the raw image, okay? We haven't done anything like, you know, cloud masking or anything, you know, removing clouds or anything. This is just raw data of the surface reflectance tier 2 data set. So you can see it has clouds. So this is the path, you know, taken the image. But Landsat is not taking on ocean. It close on the ocean. There are some satellites who's taking over the ocean as well. Like for MODIS, it has aqua and the Terra and aqua. So it has land and it covers ocean both. So the water surface area as well. So you can calculate like in the Landsat, it stops over the ocean, because Landsat's purpose is not to get the data on ocean. So you can see the path if you go for the large scale. Oh, the other thing, in the Google Earth engine, you don't need to like, you know, mosaic the images, like, you know, download the different tiles. Another advantage, these tiles, because when you're downloading a data on the USGS satellite, you cannot download like, let's say like what's your okay, let's say Myanmar, India or something. The India is not like coming like exact one image or two image, because sometimes when you're taking the part of India, in the image you will get the part of Pakistan, and some in the top you get the Nepal, over there you can get the Bangladesh, and yeah, so these things, like you can have like different images that can be happen, because satellite or the image cannot take for like exact location that you want. So when it comes to like the ArcGIS, if you use the ArcGIS by using the raw data rather than using the Google Earth engine to process the data, and whatever the things that you are doing on ArcGIS you can download and do, you need to do on the ArcGIS, you need to clip it, then you need to mosaic the images and all the process. It's a huge process. In the Google Earth engine, you don't need. You just upload your shapefile, like the area, like the shapefile of India, but shapefile of India is little bit big. Let's say like a small part, because it has a processing limit. I told you, like for Sri Lanka as well, it's a small country, 65,000 square kilometers, but the entire country cannot process. It only processes one district of my country. So it has some what we call limitation, but this limitation can be overcome. How? In the coding we have loops. No, loops, like loops. Loop is something like, you know, Google, rather than you ask your entire country to be run by the Google Earth Engine, asking in the code, run one by one. Like, you know, in the coding, you have loop means, let's say like you are counting numbers, some variable from 1 to 10. 1 to 10. So you are asking your code, first take number 1, calculate, process, then again go into the code top to process the number 2. So one by one, the Google Earth Engine will be run. The thing in the Google Earth Engine is within 1 minute, not the entire code, doesn't matter. You can run anytime. There's nothing limitation like that. But the process you can give for 1 minute, like one period, one time, is limited. It's computational limitation, not something like you know, for example, if you are breaking like, you know, one part by one part, you can do for entire world, there's no problem. But if this is for Landsat only, but if you do for the MODIS, the area is large, because one MODIS image is covering a huge area, 30 kilometers. In here is 30 meters. The resolution of the image is being go. If you go for something like paid satellites, like let's say a worldview series, worldview, it has like centimeter level. In the worldview, if you see an image of a worldview, you get a clear image. It's like, you know, you took a image in the ground from a DSLR camera, a close. You can identify the people. So these satellites are not available freely because the data is huge. And some of the satellites that most of other countries have, like I think India have some satellite series. So those satellites only available for Indians. So things like that. So you can use within the government. Some government have their own satellites they can use. Like there are some European satellites that we don't have access. Very few satellites we can like publicly access. So publicly accessed satellites don't have this much big resolution. The maximum goes for like 15 meters. Sentinel goes. Sentinel goes 10 meter now. Yeah, okay. Sentinel is going. Sentinel is a European satellite series. Sentinel data also you can use in here. In the Google Earth Engine, you have the European satellites, the Japanese satellites, and the US satellites. Sorry? OSS. Yeah, we can search on the data set. I haven't used before. Is it available in the USGS satellite? Yeah, this one, Google Earth Engine only, like, you know, guys, in the Google Earth Engine, not only the dataset that is available on Google Earth Engine that you can use, like you can also upload the data into the Google Earth Engine and use the processing power of the Google Earth Engine. That's no problem. But I'm not advising to do something like, you know, like your own government information, like, you know, some satellite into the Google Earth Engine, because Google Earth Engine again is publicly in the agreement. The United States government will be using those data. So some protected data do not upload into the Google Earth Engine. So it's better something like public level, some environmental data that we are doing is okay. There's no problem. Okay, let's just like first go through this code. Anybody in here can explain this code to me? Anybody who can read the codes? Anybody can read the code? Sorry, I'm blocking the view. Anybody can read the code? You can. Okay. Yes. And then again, apply scaling factor like we have to scale that, like for if we need RGB, we have to scale like which bands we are selecting and which we are not selecting. Correct. And then again, for multiple like merging multiple bands for one. It's mosaic the bands. Yes, yes. And again, the dataset dot map, like we have to make a scaling for our study area. Yes. Then again, visualization, what we are seeing like from band 4, band 3, and band 2, from maximum to minimum, like minimum value for minimum value, what is the maximum for our band, what we are going to see. Again, map center is for like what is the study area. We have to choose a like center of the whole study area so that the band can have like cover the exact range or something like the center to like okay. And layer means what layer we are using, like what layer we want to see, like color composite and color composite, there are multiple layers. Which layer we want to visualize that. Okay. A lot of things you have told is correct. Guys, listen. You guys didn't hear what your name is Divya, but Divya has told. See, because Divya has told like you don't have a background of software, no? See, she don't have that much of background of software, so she have told about the things like what are the things. So you can also give a try. She have told is correct, mostly correct. Like the data variable is asking the data to come is correct. In here, filter dates means what are the dates that you need. Apply scaling factor. In the image, you code like RGB colors. You remember? So in here as well, you need to tell what are the. You can write on this one as well. What are the band we need? So we call the bands, and we there's also two. The variable has been opened: optical band and thermal band. So in here we use thermal band and optical band. We have been called, and the thermal band and optical band. What are the what is the yeah. Yeah, so this one is the blue. This one you can check by going into the. Yeah. Sorry. See, we are calling in here the bands that we are calling. So that's what they have been applying scaling factor means. This application of scaling factor is different from one one data product to one data product. So this will be provided by the Google Earth Engine itself when it providing the data. So you don't have to like think on this one again. What is this dataset? Dataset dot map applying scaling factor. In here, what we have done, we have in this function. This is a function. Function in the code is something like already something like applying scaling factor. We are telling the process of the scaling factor. What is the scaling factor? This is the function. So these are the bands that we are using. What we did in here in the data set is over there. We apply the data set, this scaling function that we have called. Let's say like we have we have the numbers, a set of numbers. We have set of numbers, but the computer don't know what to do with numbers. We are telling you need to add these numbers. Like add means like let's this 1 to 10. 1 to 10, you have numbers. What we have doing, adding these numbers 1, 2, 3, 4. So this is the function. Okay, this is the function. So we are telling this function of doing up to the n. N means like this one n 10. Doing this one for the number of 1 to 10. We are telling in here. So that's what that we are telling. So we defined the plus first because computer do not, the Google Earth Engine don't know what to do. So we told about applying scaling factor, which means something like adding, one number to one number to one number adding. this scaling factor. We told in here to add into the code that we are doing. So that is dataset equal dataset dot map apply scaling factor. So this is visualization. What is visualization? Yes. So when it comes to like see, you need these bands. The SR before the band 4, band 3, band 2. So these are the bands that we need. And we gave the minimum value and maximum value. When it comes to like, I told that we are going for in the end of our everything we will be doing together, we will do. Not only me, you will also do on your codes. So it will be not something, because this is just like giving today introduction to Google Earth Engine. Tomorrow onwards, we will start like, one by one. Maybe in the end today also we can also start together these things. So in here, what we have been done is giving the visualization. These numbers need to be added and these things has to be showed. And these are the bands that we are using to visualize. Where to visualize? This one. Sorry, I'm not coming to that one. Map.center. Map.center, which means, again, in the Google Earth Engine, we have, this is the coding place. This is where we code. This center place is a coding place. Visualization area is here, where you can see whatever that you have been coded in here is being visualized in this section. So let me tell, for example, this area in the Google Earth Engine will be all the scripts that you have been done. So the things that you have been saved. And the other one advantages I'm adding, because I'm not a person who's like, typing everything. In Google Earth Engine, let's say like a project that you're working, in ArcGIS, you need to carry your laptop or you need to give any desk to someone. But Google Earth Engine, you don't need. You can just send your project into a person. Let's say me and Dinesh is working, but during the Corona time also we worked. So we don't need to like, go for the office. We can work like one part of the things I'm checking and the other part, rest of things he can do. So we just need to send by get a link and share with his Google account. Then together, we both working on the same project. In the down, you can see like some of the projects we both have been worked. So that is one of the things that is the easiest in the Google Earth Engine. One advantages I added. So in Google Earth Engine, here is the place where the things are saved. All the things, like this is the scripts and these are the documents, this EE image collection, because these all the things are like download, like saved in here. So you can see like EE algorithms, EE arrays and everything in here. See, using of different kind of data set like functions that has been already inbuilt. Just don't think too much on this one. Assets. Assets means, give me one, sorry. Anybody from Uzbekistan or some other country? Near to the Russian area? No, no one. Okay. So this is Bukhara, Samarkand, Tashkent. This is entire Uzbekistan. So these are the provinces of Uzbekistan. This data you cannot see in your file. If you go right now, your assets are zero. There's nothing. Maybe there are some, but not the things that you have. Anybody can see any assets in your files? The Google, you can see what you have. Oh, you have already worked on something, no? Ah, that's right. Your data. So assets are things that you have been uploaded into the to the Google Earth Engine. For example, I have worked some research on Uzbek. I'm currently working on. So Uzbekistan. So I have uploaded some of the data, the shape file. I think you all know about the shape file. The shape file data into the Google Earth Engine. I already uploaded. And this is previous IMSA I have uploaded. This is the China. NIBS country means Bangladesh, I assume. And this is like Anagamagri and Bagmati. I think this is Nepal. Because during my master's, I did my research to the Nepal. So my master's research was on land surface changes, the past, present, and future. So future means I have run a model. Yeah, we have different models in the land surface classification, LUSC classification. We can run like CA marker model, and we have CK marker model, and the other model I forgot. There are several models you can search. So I have run my things on CA marker model, which means like I uploaded some of the data. You can find the best model that you wanted to run when it comes to land surface classification. But whenever that you are using a model or something, I think everybody in here knows, most of them are PhD. You need to first like check whether this model gives a accurate what we call the data, which means we our model past and forward. Before we run for the forward, we run for the past, which means we give like some of the old data and check whether this model is accurately coming onto your location, the research area that you have been chosen correctly or not. So for my area, the CA marker model for the Nepal area, exactly Nepal, the entire country, the CA marker model came correct, so I have used CA marker model. So the other data is like, these are GPS data. So GPS data is something like, anybody here know about the Garmin machine? Garmin machine? You know Garmin machine? You're working military? Ah, that's right. Anybody? Because like Garmin machine is like, you get like the GPS track, usually using by military. So whenever that you're going, you can also use the Garmin machine. It's a little bit expensive, but better than your iPhone or any other the GPS positioning, because Garmin machine use satellite series. You can go for the outside and you can get the satellite the data of your exact position. So those data I have been added in here, the GPS machine. So these are like GPS data that I have been added inside to my ArcGIS. Sorry, Google Earth Engine. So these are the data that you can add. And when it comes to here, you can see this side. This section is the place that we are doing the coding, everything. Whatever the things that you type, you are typing in here. So you can do everything in here. So in here, let's say when you type, you can get a link and manage links and copy the script path. Everything. Whenever that you are working with a friend or some group or someone, you can use this one. And in here, when it comes to run, you remember when I open this one, I run. Run means I run with the, you can run with the profiler or run. Run with the profiler means if you want to like check on the bugs and things, the places that has been going wrong and everything, you can check with the profiler. And this is reset, everyone know, clear the script or something. And this is for apps. Dinesh have experience on apps. If anybody is wanted to talk, I'm not going to talk this one. Creating apps. So Dinesh have created one application based on, I think, based on the deforestation project I have worked on. So that's how, that I have worked on the deforestation code in order to create the application that has been used by the end user, because I worked in the research the place. Our end users are the people who do not have any information, like we are giving meteorology information for the public, but we are not giving the the entire what we call the chart, the wind charts, everything we don't give. So we just give the things like graphics and things. So things like that, you can take whatever the information that you have been generated as a user-friendly version to the person who do not know anything from the apps by the Google Earth Engine itself. So he can go and put the different layers. In here, you can find different layers. When I run a code, you can check like different layers. So these layers also, they can be changed easily. Like, Google Maps, how Google Maps has been created. Different layers. It also has different layers. Whenever you need traffic, you click on traffic, which means it opens traffic layer. Traffic is a different data layer. So in Google Earth Engine as well, we have different layers of data. So these layers is one by one we are putting. First we have the normal topographic map, then again we are putting like DEM or something on top. You can find in the Google Google Maps as well. And after that, whenever you open traffic, which means on top, sorry, before the traffic you need the road network. You put the road network layer, then on top of the road network layer you are putting the live traffic. So whenever you put a lot of layers, which means layers of data will be visible and you will get a big picture. So same way Google Earth Engine also works. It also have layers. So when you created an application, apps from here, it's a different process. I told you again, I'm not teaching that part. It's a little bit complex. But whenever you created an application, app from here in a mobile phone app, you know, everyone know apps in the mobile phone, no? So this app, it will also create something like Google Maps, but that Google Map is not the Google Map. I mean, it will be like deforestation Google Map. Where to find the places that you have been done the research. Yeah, whatever the thing that you have been done a research, you can create and generate like application, because it's useful for the people. Again, if you are doing a project for the government or something, if you have an end user in your project. And this is the inspector. You can, you know, go anywhere, then you can create and you can get all that exact point that you have been created. When you go for the inspector, you can get all the information of the place. Go for the inspector in this area where the visualization is happened, you will get like something like cross. See? And whenever you run the data and on top of the data you downloaded, it automatically give you how many image collection, 19 bands, 3 images. The places that I have been already run, it has been used 3 images. I told you like one location is not coming from exact same thing. So it has 3 images, and Mosaic has image 19 bands, and series 3 you can see it gives like the charts about how much about the bands and giving everything that you need. And the console is the place where that everything like running, whatever that, you know, let's say I think you all have tried Hello World, print Hello World. So the place of the Hello World coming is the console. So let's say like you're checking like how many land area has been coming up. So the place is coming on here in the console, and the task is the place whenever that you put. You can go to the tab whenever you put a download, or you can see like so many things that I have been downloaded. I told you I'm working on ArcGIS these days. So these are the ArcGIS data that I have been downloaded. So all the things that you are downloading, all the tasks that you are giving, anything is coming to here. Then you go for download and you put in the data into the Google. You can put different places, but I suggest you to put onto the Google Drive. Is easy than connecting with other drives. You can also connect other drives into the Google Cloud, but it's complicated. Why you can use the Google Drive easily. So I will just run a small code, and what I have been done. Okay. Okay. Okay, I think I haven't fully done this one yet. Don't think about the inside, whatever that I have been done already. This is just to show you guys. So I already pressed the run, so I have to wait until it's being run. So you can go for the console and you can see everything. Okay, see in the console. But to get to the console, you need to write that print whatever the things that you have been done, like, you know, print whatever the let's say like if you put print dataset in the console, it will be give you everything like what we call like the data bands and everything in the dataset that you are using. So this is for the console, the use of console. I wanted to show you the use of console. And this is the task. You see, different images and the LUSC image in the last. See, in the visualization, oh, I think run it, I click it 2 times. So the same layer again multiply, otherwise just ignore the other layers. So these are the layers, you see, layers by layers on the place. Now it's like computing and putting easily. For example, I just run this code, anytime I want it, just change the date, I can run. But if it's like, let's say in the ArcGIS, you need to download the data. You need to do the atmospheric correction of the data if it's the raw data. The process again and again, you need to do like one by one, time consuming. In here, when you have the code, you don't need to download. I change the date, I run. You get all the data you need. It's easy. I do have the code. I can run anywhere in the world easily. If I want in Myanmar, soon I get the image, I will run. If I want to write the publication, I will write and publish. There's no problem. I can easily publish because I don't need to download the data and again one by one. I have the code, I download, I run, I get the data, I have the place that I want to do, then I done. That's it. So that is the most easiest thing of the Google Earth Engine. Okay, I will just remove all the layers one by one. I will show you. Okay, just don't think about other things. I will teach you everything like before you go like one by one how to do of the land use land classification. Anybody in here know about the land use class classification? Okay, I see the Rebecca's student. Professor Rebecca. Okay, sorry. Professor Rebecca. Okay. Wait for the loading. Sorry for the internet speed. It's a lot faster. See, my laptop is like I bought on 2016. This laptop I bought in 2016, but I don't use my laptop when it comes like I use ArcGIS. ArcGIS I never use on here. Not only ArcGIS, if I run MATLAB or other thing, like there are some code that I have been run on MATLAB. My computer is also like have a good graphic card and a good processor than this one. It also little bit getting slow when the MATLAB code has been run. If this code I put onto my the laptop is don't even start the code because it's like end of the pod, dead on spot. But in here, this kind of big process also I can run on my laptop. My laptop I basically use for presentation and only these things. If I'm teaching on ArcGIS, I never teach on my laptop. I will directly go from any desk to my computer in my home. It's easy than using. Okay, the layers. I'm going for the layers. What is Landsat, the composite I'm in here? The Landsat composite image that I am loading, you can see it's loading now. The layer is loading in here. So this is the raw image that I have been used. Again, this image, see, I crop it for my place as I needed. And the next one that we have, the Bukhara region, I think this is Uzbekistan. Anybody know Uzbekistan, where it's located? Not India, never India. No, not close to India. It's close to Russia. It's close to Afghanistan. It's like a stan. Near to Kazakhstan, Uzbekistan, Afghanistan. Pakistan is down than Afghanistan. Turkmenistan, they don't have a border with Pakistan. Yes. Yeah, it's in the middle. It don't have a sea, but it have a lot of, yeah, not like, let's say, so much like a desert area, like not people living. So you can see a lot of sand over there. But they have, from the country-wise, they have natural gas as well as uranium, one of the expensive stuff. but Russia is controlling that. They don't have the ownership for that one. So this is NVIDIA, sorry, not NVIDIA, NDVI. Anybody know in here NDVI? Normalized vegetation, normalized vegetation difference index. Normalized vegetation difference. Yeah, normalized differences vegetation index. Sorry. NDVI. I think you have done the NDVI on ArcGIS. You have already done, no? One image taking. Is it easy to run the process? Little bit different. This one, you can run the NDVI for entire world any second, but you don't need to download like the image again and again. So this one NDWI, which means the water index, the same way the vegetation index using, we are using water index for finding water bodies, which means like lakes, inner ponds, whatever the like rivers, lakes that we want to find within the image. Sorry. Yes, wetland is also possible, but use the dataset of Landsat, not something like Modis or something for like large areas, because for finding the wetland you need to find a good what we call yeah, Sentinel is much better. Yes, yes, yes. NDBI means the build-up index. For using the man-made things you can find from this index, it is easily coming. So you can see like the water bodies, they have a lake in here. This is NDWI, water index. You can find the water sources, the areas, and the same way that we have the snow index to find the snow, but this region no, but in Uzbekistan they have, in Samarkand they have top of the mountain, they have glaciers. So those glaciers you can find. So based on the area also you need to change the indexes. Okay, you can code the indexes, there's no problem. Indexes are also over there, you want to code, but you don't need like, you know, the snow index on Saudi Arabia or someplace. There's no snow. So based on the place you can change the indexes. And this is the LULC, which means the land use land classification that I have been run. So based on the land use land classification, see, one layer by one layer in the visualization area, you can like come up. This is build up index. See, easily, it's loading. If the network speed is good, then it's working. You need a good internet connection and a computer, that's it. And a Google account. Yeah. You can use the tablet, no need the laptop. One time I remember I ran this one and in the progress meeting on the mobile phone. When my supervisor, not supervisor, main supervisor, head, director general of the center wanted some information, I ran the code on my phone. No, it's working because it's using Google. Just use my phone and I showed him this one. Then he zoom and check. On their service. Okay, then we have learned a lot, and shall we take a small break? I think I have teach a lot. 5 minutes break or something? Okay, go for a 5 minutes break. Then we will finish. We will try to start something to code today with you. Okay, guys. Hi. We can start again, no? Because we have to stop around 8:30. You guys hungry as well? Maybe you need to go and sleep as well of the class. Okay. So we have like learned a lot about the Google Earth Engine, how it has been going on and everything. And now we will start, guys. Okay, now we will start to add a region of interest. What is the region of interest? The place that you have been choose to do the research. So let's say it's your country, maybe any place. There are several methods that you can mark choose the research of interest in the Google Earth engine. From a shapefile is one method. Again, we can create a box. Let's say like you don't have a shapefile with you right now, so you can just create a box or something around the place on the map, and this around the place, or else you can choose a polygon. Polygon means like select from one place to one place. Let me show you how to do this one. Okay. So the basic map is in here. So what is the best area that you can choose? Okay. I will choose my country. Oh, are you on Africa? Okay. But the problem of me is like I don't have the ground station. Like, you know, when I completed everything, I don't have like, again, when you do the remote sensing, you need to have how the environment, you know, you need to have some understanding. Like, you know, that's the problem of mine. So I know about the area of South Asia, any place, and so I'll just go for my country. You can choose your country because you have more information. Because in the land use land classification, when you're running, you need to know about little bit information about the ground. Like, you know, in this area you have like something like a forest or something that you used to have. You will get in on the same time on over there. I also again told you the ground confirmation is like like a must something, because you cannot just rely on the remote sensing data. You need to have some understanding about the topography around the area that you are doing the research. I think the people who knows in the meteorology area, the weather patterns we are searching on the countries like China is a different way, and the South Asian area is different way, because in here in China they are going with the prediction on the frontal weather systems. But when it comes to like my country, there's no frontal weather system that we are much considering. We are going for monsoon seasons. So because we are based on the wind patterns at the time, like which side the wind is coming, because we are an island. So again, you need to have understanding about the topography when you're doing for the land surface remote sensing as well. So this is the place that I have been, so I will choose. So this is the several minutes. This is the draw shape is also one method, which means, oh, these boxes you can just grab from here and you can expand, do anything, okay, as ever you wanted. So to show you guys more under, like, you know, in the biggest place, I'm just expanded it to up here. Then these icons, this is hand icon, which you will get when you click this one. You can just move on the map. See, the map is easy. And this is mark the point. In the ArcGIS, you have told about the polygon point, polygon, polyline. Have you remember? Because in the ArcGIS we have different type of method of data showing: point, polyline, polygon. Shapefile also, like shapefile is a polygon. Shapefile have different types. You know, point data. Point means, yeah, point means one point. It is one of the shape. Just a one point. It's a shape. Shapefile. It can be a shapefile. This is polyline. It can be a shapefile. Anything. It can also shapefile. I think most of you familiar with this shapefile type, but you cannot go like most like roads. It's polyline. It's not a polygon. It's polyline. So point data. They say like in the map you're marking a hospital. It's not a polygon. It's a point data. Exact location. But if you go for the area size, then it will be like a polygon. Like let's say the area of the hospital is a little bit big. So in here you can see point data, polygon data, which means draw a line. When you go there, add a marker, which means the point data, and here is the polygon from a shape. Shape means if you click this one, you see you can draw around any places that you wanted. Okay, see this way. And the other method is you can create a box. So when you don't want anything that you don't want, just go to here, you select on any shapefile that you have already done and press delete. Then it will be deleted. Okay, the same way you can move the shape that you have been created from the hand. Okay, you need to use the hand in order to move. Maybe some of the people knows about the Google Earth Engine, it might be feel boring, but I'm trying to go for the basic method so everybody can have understanding. Okay, just give me some time so they will be familiar more. And after that, you can see, like you see, I go with two different type of methods. One is a rectangle and a shape. So when I created a different geometry type, it creates on the different files. Like let's say, like if I go for in here, I can only go this type of shapes anytime. It has a color and everything. So in here, you can change the name of the area that you have been selected. How I went over there, again I will show you. I will create one of the file that I have been created. Okay, the geometry type also I can go here in the edit player property and go and delete from here. Okay, if you want to create the geometry type, you can go here and delete. Okay, and delete. It has been deleted. See, anything that you wanted to do, you have to go for the geometry layer. That you can see all the layers. You can even add a layer, new layer, and go for here for the settings, and you can change the name. In here, I will mention it as ROI, region of interest. You can put your name, maybe the area that you're using, like Colombo or something. The basic, I will put ROI. In here, you can consider as it's a geometry type, feature or feature collection. These types I will teach you later about the import as for the file. And you can choose, even change the color as well as you wanted. Let's say for the green, and you can say okay. See, it's changed. So this is one of the type that I have been created ROI. So you will see that the changes that I have made right now, if you go in the top, see, it has mentioned in here. It's a polygon. See, I told you about the polygon, polyline, and point. So this code is being recognized. The one I created is a polygon, correct? And it has 9 varieties, which means the point, because it has been changed from 1 to 1. So if you put like one point data, it only have one variety because it's just a 1 point. When it comes to polygon, it covers lot area, so it has different varieties. And this is a variable. What I have been created in my code is a variable. Variable means something I open, and the name of this one is ROI. I changed the name from the settings of the down of the visualization box, but I can also change the name in here. IMSA. See, I can change my variable name. There's no problem. In here, these are imports. Imports means for my process, I am importing whatever things, all the variables that you are adding, the shape files and everything will be come into the imports, because this is import. It's actually a variable that has been defined on top. So these variables we will be using inside of our code for our process that we are doing. So again, I will change for ROI. It's easy because that is the region of interest. That is one method of adding a region of interest. There are 7 methods of adding region of interest. For example, if you go for assets, I think I do have Colombo. Yeah, this one. So when you have the shapefile of the exact area that you wanted, that you have been downloaded. Anybody know how to download a shapefile? You can also create a shapefile. There's no problem from the ArcGIS as well. But you can also have, you have admin boundaries in your country. You can download and you can click from the ArcGIS the area that you wanted, exact province or something. Then you can upload to here. I will show you that. Sorry, that uploading method as well. And in here, I will show you. I already have the shapefile. I already uploaded into my asset. The area that I am talking about, this Colombo. Colombo is the capital of Sri Lanka. If anybody don't know, then I will be like putting my ROI. This now come as a table, so I can just delete this polygon and rename this one as ROI. Okay, but it is not showing. Why it is not showing? Because we haven't put this ROI from the visualization map, because there's nothing that we return to show this one, visualize this one, map, add layer or anything. But we have a ROI, we have been created. So there are 2 methods. You can add your own shapefile, or else you can create your own place. In here, most important thing is your ROI. ROI means region of interest, the place that you wanted. Because if it's a bigger area, your research will be like, not happens in here. I told you about the computation limitation. If you have a bigger area, then you need to put small ROI, then run a loop. Loop means after one ROI, after one ROI. So this is the ROI. So ROI has to be changed. Then you need to put a loop from 1 to 10 or something like, this is the one ROI 1, ROI 2. So you're running a loop go for the 1 ROI, ROI 2, then ROI 3. Same process. Okay. Now we have already done. So in here, also you can see that the file that I uploaded, if you click in here, you can see my shape file. It's loading. So this is the shape file that I wanted. So let's go and select some data set. Now I have a ROI, region of interest. Can everybody put some ROI into the place? Maybe something, a box or something. Come on, let's try with me. Let's try to code with me. Oh, do we have time for? No, I don't think so. No. Okay. Okay, we have okay. Okay, now I will go. Okay, I will show you the method that I am following up. Okay. I have been already selected the ROI, region of interest. So first of all, I think today we don't have time because I need to teach everything, and you also need to type. It will go for like another 45 minutes if it goes. So I will just say about the methodology today. So tomorrow, first thing that we are doing is starting to code. The load the data. I already told you we have already done with the this is just the first step, okay? The methodology is much bigger. This is just the first step, and this will be done on tomorrow, okay? Tomorrow entirely we will cover on here. Region of interest we will be taking, then after that we load the data any sets, not only Landsat, but I'm doing in here on Landsat, but you can also use Sentinel. Maybe if it's a bigger area, go for a MODIS, maybe like, you know, entire South Asia, entire African continent, or entire American, North American area, like Canada and USA, or Europe. You go for like MODIS or something, not like Sentinel, because it's easy. And then we filter the dates and region. This is where that we are using our ROI, region of interest. We first define the area that we wanted. So this data, full data set, we are filtering our region and our dates. Then after that, displaying the results. So even though that I have been started this coding, until I come to here, you cannot see anything, because whatever the process that I have been done, it has to be displayed. Without displaying, it will not show in your visualization box. And within this one, after I do this first process, I will show you how do the cloud masking. Advantage of Google Earth Engine is we can remove the clouds. How we remove the clouds? I will tell this one slowly today. Just not to, first thing on today. So we have different image. Let's say like we take on 1 month, maybe we have 2 images. We go for a 1 season, we may have 5 or 6 images. For a 1 year, maybe have 10 images on the same place. The place on the earth, we may have different areas. So on the, let's say 1 month we get 1 image. For a 1 year we have 12 images. So all 12 images we are like stacking one after one after one. Okay, this goes up to 12. And 1 image we may find on our place there's a cloud. The cloud masking works, we remove this part. So we have a no data zone on 1 image. Then we use this one in order to process from other images. This place, they use the mean average of a 1 box, because in the image, which means the resolution of the image, if I say in the Landsat we have 30 centimeter, yeah, 30 meter, sorry, not centimeter, 30 meter resolution, which means one box means like pixel. When you take, yeah, 1 pixel is 30 meter, 30 meter. So they take the average of these cells, because 1 image in here is 30 meter boxes, a lot of boxes. They take the average of each box in order to show the null data, no data. But if you, in your research, let's say you are taking the yearly average data for your research is useful, then you can use the year, or else you best go for seasonally. Because some of the research for land use, I think it's better. Like for earthquake, if you find the Myanmar earthquake, that's why I said I cannot go for use for the cloud masking, because it's just 1 image I needed. Earthquake happened, sooner they will build. Like something happens in Japan, maybe like within 1 week or 1 month they will be happen, because they get frequent earthquake. Earthquakes are not new for the Japan, so they build so fast. So for countries like I'm not sure whether how Myanmar one is too much big. So I think next image we can see how much things. So when I find an earthquake or landslide, I need the exact date. I cannot use the cloud masking on that one. So I need the data where there's no cloud if to find. I found 1 data on the Myanmar on March without cloud. I'm hoping no clouds on the April one, then there will be okay. Cloud masking you cannot use on the places like earthquake, landslide finding, but for land use, land classification, like how much land the people have been using or used or something like that, we can use obviously, because I don't think one building is being built within 1 month. So it has to come over the way. So major changes are not happening within 1 year things. You can use 1 year range of data. So we will use the cloud masking to remove the clouds, and then after that composite the image collection, and we will go for the display result. Because in the cloud masking, we are not using one image, we are using several images. So when we use the cloud masking means we remove in the images the clouds, then we composite the image collection, then go for the display and results. So tomorrow we will try, this is actually 2 methods. This first method you can go for like some things like earthquake findings or something. The second method that you can go for yearly average data. So second method means then this will be incorporated with each other. So tomorrow we will go ahead with this one, and any questions that you have for today?